This will be a follow-up video on the one I did earlier dealing with graphing of linear and nonlinear inequalities. In this case we have systems of inequalities, and they could be linear, they could be nonlinear, or they could be a combination. So in this case we look at the first one. We have x squared plus y squared less than or equal to 64 and x plus y less than or equal to 8. So this will be just like just graphing a regular inequality. You first graph the boundary and then decide what side of that boundary you're going to shade. Or if it's a circle, you decide whether you shade inside the circle or outside. You do each one individually pretty much, and then decide where the common solution or the common region is going to be. So the first one, we make it into an equation. Ignore the less than or the greater than and just make it into a straight equation. That's going to be your boundary. So x squared plus y squared, again you should recognize this as a circle. 64 is 8 squared, so the radius is a circle, center at the origin with radius of 8. So center would be at the origin 0, 0, and then it has a radius of 8. So let's suppose this is 8 units, so let's say that's 8 up there, 8 over here, and over here we have a minus 8. Down here we have a minus 8. And remember, if there's an equal with the less than or the greater than sign, that means the boundary is included as part of your solution set. So in this case, it's equals, so it's going to be a solid boundary. So we draw the circle. Okay, so it passes through that point there, 0, 8, 0, minus 8, 8, 0, and minus 8, 0. Technique we used last time was a test point. So pick any point that is not on that circle, could be inside or outside, and see if you get a true or false statement. So again, my favorite point is the point 0, 0, as long as it's not on the graph or the boundary. You can pick it. I could pick 9, 0. I could pick 0, 8. Okay. I could pick some point over here, 10 and 20 up here. But again, we go the easy route, so I'm going to pick 0, 0. So if I put a 0 where the x is, a 0 where the y is over here in the original inequality, I would get 0 plus 0 is 0. 0 less than or equal to 64. If that's true, then I shade everything on that side. So that's a true statement. 0 is less than or equal to 64. So I'm just going to draw some arrows this way just to say that I'm shading inside the circle. So we were doing just a regular one inequality. Just the first one there, then the answer would be everything shaded inside the circle. The boundary would be included and everything inside. But now we want to find the graph for the second one, or the solution set for the second one. The common solution for both of this will be the solution to the system. So let's see. The second one is the boundaries aligned. So again, I make it into an equation. X plus y equals to 8. So 2 points determine a line, so I can go ahead and pick a value for x, get a value for y, or pick a value for y, get a value for x, plot the 2 points, and then draw your line. So here, again, I'm going to go with the intercept. So let x be 0, y is equal to 8. Let y be 0, x will be 8. Okay, so the line passes through the point 0, 8, which is on the circle. 0, 8 is on the circle, and 8, 0, which is also on the circle. But that's okay because we're just drawing the line. And then I would just draw the line through those points. Through 0, 8, and 8, 0. And then I just have to decide which side do I shade. Above the line or below. So again, I'm going to use the test point 0, 0. So I put a 0 where the x is, a 0 where the y is, and that gives me 0 plus 0 is 0, so that would be 0 less than or equal to 8, which is a true statement. So I would shade everything below the line. So I'm just going to go Okay, the arrows go this way. So I'm shading everything below the line for that. So the solution set for the second one would be everything below the line, as the arrows indicate. And for the first one, this the inequality, that represents a circle for the boundary. The region is inside the circle. So I'm shading everything inside the circle and everything below the line. Where's the intersection? Well, let's get it fall right in here. So basically you would shade everything in here. The solution for the system would be everything inside the circle and below the line. That's the intersection. Yeah, that's your solution set. So let's clear this. That is, the boundaries are two lines. So for the first one, I have x plus y is equal to 3. So we graph that boundary. So I'm going to use the intercepts. Let x be 0, y will be 3. Let y be 0, x will be 3. So I go up 3, 0. So let's say that's about right here. Then 3, 0 this way. That'll be right here somewhere. And then I draw a line through there. Okay, close enough. So we have that. And then I want to know which way do I shade. So again, I'm going to use the test point 0, 0. Just like I did in the other problems. You can pick other points, it's up to you, as long as you don't pick a point that falls on the boundary, in this case this particular line. And just plug it into the inequality. If you get a true statement, you shade everything on that side of the line. If you get a false statement, you shade everything on the other side. So I'll put a 0 where the x is, 0 where the y is. That would be 0 less than or equal to 3. That's a true statement. So the solution set for that inequality falls below this line. Okay, for the second inequality, okay, so the boundary again is a line, so 2 points determine the line. So I pick x to be 0, I'm going to use the intercepts. X is equal to 0, then y would be 12. And if y is 0, 4x would equal to 12, so x would be 3. So the other one, then we pass to the point 3, 0, so it's the same as this one actually. 3, 0. And then the point 0, 12 would be, say, somewhere over here. We'll get a line. Okay, so those are the graphs for the boundaries for both of those. Now for this one, again, I would pick a test point. Again, I'm going to use 0, 0. So if I put a 0 there where the x is, 0 where the y is, that would give just 0 less than or equal to 12. So that would be true. So for this one, again, I'm shading everything on this side of the line. So I just draw the arrows. And then just visualize that. If you extend them, where's the intersection? Well, see, this one's going this way, this one's going here. So in this area right here, there's no intersection. This one coming this way, but the other one's below, so there's no intersection there. So the intersection falls somewhere over here. So your solution set for the system would be that. Right there. Again, these are both linear inequalities, linear system, same sort of thing. So I'm going to let x be 0. So I'm looking at the first one, x plus 4y equals to 8. Just saving some time here instead of writing this out. It'd be x plus 4y equals to 8. That's the boundary for that region. So x is equal to 0, 4y would be 8, so y would be 2. And if y is 0, x is 8. Okay, so this line is going to pass to the point 8, 0, so that would be right here. 8, 0 is over here. And say 2, 0, 0, 2 is over here. So I would draw a line through those 2 points. Okay, the line passing through 0, 2 and 0, 8. And the region that I want to shade here, well, again, using 0, 0 as my test point, I would get for the first inequality 0 less than or equal to 8. That's true. So this would tell me that I would have to shade this way. So just a few arrows to indicate which way I'm shading for this one. So if I was just doing the first one by itself, the solution set would be everything below this line would be shaded. And because it has an equals, when it has the equals, remember the boundary is also included as part of the solution set. Now for the next one, here and this one here, let x be 0, 2x plus 8y equals to 0, so let x be 0. And I would 8y equal to 0, so the line passes to the point 0, 0. So let me write the whole equation here, 2x plus 8y is equal to 0. So replace the x by 0, and I got y to be 0. And if I replace the y by 0, x would be 0. I get the same point, so I got to pick something else here. So let's pick x to be 4. So x is 4. 4 times 2 is 8. Bring it over, that's minus 8, so y would be negative 1. So that's another point for the second line. So 0, 0, line passes to the point 0, 0, and 4, and say negative 1. So that would be that point right there. So let's draw the line through those 2 points. And notice in this particular one I can't use the point 0, 0 because the line passes through 0, 0. So I had to pick some other point. Pick a point over here somewhere, 2, 0, which falls between the 2 lines. Okay, we're above this particular line. So 2, 0 gave me a true statement. So I would put a 2 where the x is. Here. That would be 4. And a 0 where the y is, that would be 0, so it would be 4 is greater than or equal to 0. That's true. So for this one, I shade everything above the line. Okay, so for the line above, I'm shading below it. For the line right below that one, I'm shading up. So you can see that the solution set is going to be everything between the lines. If I were to extend the lines, the intersection comes in between. So I'm shading everything between those 2 lines. And actually those lines are parallel. They have a slope. They both have a slope of negative 1/4. Okay? Just to remind you, if you have a line solved for y, in the form, say, mx plus b. You have it solved for y. The coefficient of the x is the slope of the line. So if I solve the first one for y, make it into an equation, solve for y, I get y is equal to negative 1/4 x for the first equation. And of course it has the plus 8 over here. That's the boundary. And of course, because I divided by 4, this is actually 2 here. Okay, that's actually going to be 2. So solving the boundary for the first one, I get y is equal to negative 1/4 x plus 2. If I solve the second one, for make it into an equation, solve for y will equal 2. Take the 2x over, that's minus 2x divided by 8, that's a negative 1/4 x. And of course the main thing we're concerned about is the slope. They both have the same slope, so that justifies that the lines are parallel. Either way, I shade the region below, between the two lines to get the solution set for the system. And then number 4, that's a nonlinear system because one of the inequalities has degree of 2 on the x here, exponent of 2. So let's look at that equation. Y is equal to minus x squared plus 4. That you should recognize as a parabola. It opens down. And y equal to x. I make the second one into an equation. That's a boundary, that's a line. So let's see, this one has, this will, without the 4, this will have vertex at 0, 0. At the 4, it moves it up 4 units. So vertex right here, and it opens down because the coefficient of the x-word is negative. So I go up 4 units, so what about here? And this is going to come down like this. So for my test point, I'm going to use 0, 0, which is inside here, the parabola, below the vertex. So if I use 0, 0 as my test point, put a 0 there, a 0 there, that would tell me that 0 is less than or equal to 4. I get a true statement. So that would tell me that I shade everything within the parabola. So if I only had one inequality, that the first one, the answer to C would be the parabola like this. The region is the graph is included because it has the equals. Otherwise, it would be. Remember, if it doesn't have the equals, the boundary would be dashed or broken, and it is not included. Those points would not be included as part of the solution set, but in this case, it is. And then for the second one, the equation, and that passes through the point x equal to 0. Y equal to 0, x equal to 1, y equal to 1. So I can just use those 2 points and say, okay, this one passes to that point, and it passes to the point 1 and 1. So I would draw that line. So it would go something like this. So it would go through the origin, and then I notice again we can't use the point 0, 0 as a test point, but we can use the point 0, 1, because that's not on the line. And if we use that point 0, 1, put a 0 where the x is, a 1 where the y is, that would tell you that 1 would have to be greater or equal to 0. And that is a true statement, so that means we shade everything above the line. So then for this one then, we're shading everything above this line and everything inside the parabola. So that means the intersection would fall right in between here. This is what you would shade. I'm just drawing lines here, but it would actually, this would be shaded. If you also saw a solution set in your book or something, this would all be shaded. This is your solution set. So thanks for watching. We'll see you next time.